So good evening to everybody. I hope that you hear me well. At first, please accept my deepest apologies that I could be not there in present way. Unfortunately, some health issues which I have to solve during this morning. They stopped me from my trip to Brno, so hopefully next time. But today, at least in this form as an online lecture, I would like to welcome you and present you the topic of the application of 3D technologies in heritage conservation and more specifically on the emerging concept of so-called historic building information modeling, HBIM, as a framework for documentation, analysis, and long-term management of architectural heritage, which we are, as a group of colleagues, are working on during the next couple of years. Allow me briefly to introduce myself. My name is Lenka Stárková. I'm affiliated with the University of West Bohemia in Pilsen, where I'm working as an academic staff and head of the Scientific Research Center, which is focused on the digital archaeology in common. I also cooperate as an external teacher or lecturer with Palacký University in Olomouc and as a scientific researcher at the Masaryk University in Brno. My academic background is primarily in landscape archaeology, where I have focused on the documentation of archaeological heritage through the remote sensing mostly and digital archaeology. Over the past decade, much of my research has been situated in the sphere of the Middle East or Middle Eastern archaeology, particularly in Iraqi Kurdistan, where non-destructive digital technologies plays a crucial role in surveying, documenting, and safeguarding of cultural heritage. Originally, my work concentrated on open rural landscapes, employing aerial imagery and satellite data to detect, map, and interpret sites. But yet, let's say over some time, my research interests expanded also into urban archaeology and the documentation of historic built environment. This is what I will focus on today, and I hope it will fit to the excellent offer from the organizers of the summer school. When I was asking what's the main topic of the summer school and I checked the program, I saw that the documentation of the archaeological and historical architectural heritage should fit into it. This shift of my focus for urban archaeology in the Middle East reflects an increasing recognition that digital models or digital methods can provide invaluable insight into not only archaeological landscapes, but also architecture and urban heritage, especially where traditional methodologies fall short. In the context of archaeology and heritage conservation, the 3D recording has become an indispensable tool. Two primarily methodological pillars underpin this domain. I'm speaking strictly right now about the surrounding and let's say the areas of the Middle East we are working on. It's very, very different from the methodological approach which is common in Europe or in other parts of the world where you can easily choose which method you will use for documentation, which historical data set will you use for as a background or as a base layers for your project. But in our world of the Middle East, we should work only with very limited data set, like in the historical way, and only with very strictly limited methodologies, meaning the technical equipment, which we are able to use it. So I will focus on those which make very good progress in our work during the last few years. The first pillar can be called as a basic like the photogrammetry. It's widely adopted in archaeology. It relies on either sequential image acquisition, which is often referred to as like structure from motion, which I'm pretty sure you are practicing or you will practice during your summer school, and you will be great in it after you will pass it, I'm pretty sure. The second part is the stereoscopic intersection technique. At my presentation, I have an example. We were focusing also on processing of the stereoscopic imagery coming from the satellite sphere. So also the stereoscopic, like the old-fashioned, let's say it a little bit, or traditional way or original way, let's say the beginning of the structure from motion, it could be very well applied even in these days, maybe not on the photographs taken from the ground camera or the drone camera, but from the satellite imagery, it's very well working. And again, it's amazing support when you need to fill your gaps in your dataset, especially missing the digital elevation models, which we are common dealing with. From overlapping photographic sequences, we can extract the 3D or the digital elevation model. Even we can try some, or we tried even some automatic detection of the features which were based on the segmentation of the elevated parts, in this case of the urban landscape of the historical city of Mosul, which we were dealing with the project since 2014 until the 2020 or say 2021. The flexibility of using the photogrammetry in common, it doesn't matter if we are speaking about the ground or aerial or the satellite, it helps a lot or makes equally applicable to landscapes. It is possible to use it for architecture structures or even for the small artifacts. Again, we are using it very often as well as the open landscape and as well as you see for the still preserved remains of original traditional houses coming in this case of this village from the medieval period, but those remains were developed hardly and deeply during the 18th and 19th century, and they are still very well preserved in the landscape as itself. Of course, the second part or the second approach or methodology, which we are very often and we are all the time pray to be able to use it, is the laser scanning. Again, in here, as with the photogrammetry, we can divide it into two groups, the ground laser scanning technology and the aerial laser scanning technology, mostly well known as a LiDAR, which is very, very common in the sphere of the European archaeology. It's not the case, again, in the Middle Eastern, and unfortunately, we are not yet able to use even a larger equipment of the aerial vehicles, which can hold the laser scanner and helps us to scan the structures from the air. It's totally impossible, it's totally forbidden to even think about this technology from the security restrictions. So we are focusing, fortunately, we are able to use the ground laser scanner as one of the, again, most common and most usable technology, which we are using for documenting, in this case, totally mostly urban areas and individual historical remains of original architecture, even when it's partly or totally destructed, or even when it's still standing. The laser scanner can be divided into two groups, let's say. The first one is the static terrestrial laser scanner, which delivers the high precision geodetically referenced dataset, which is suitable for architectural documentation. The second group, which I will present during my case study, is so-called the mobile, usually SLAM-based scanners, which enable flexible acquisition in confined or hazardous spaces where static instruments cannot be deployed, which is very often our case. The combination of these two techniques provides complementary datasets, which is very suitable to create the hill-shaded textural 3D or the 3D model. We can use We can use either the, let's say, basic technology for the LiDAR, which is right now implemented not only with the Apple technology, which we are using very often, but in another smaller small apparatus, which you can use as an alternative, a cheaper alternative for the technology of the standard laser scanner, which is much more expensive and hardly even to transport and harder even to process the data. So also from our usage of these basic, or I don't want to call it basic, but different way of ground LiDAR, we are able to create also suitable 3D models, even the ground plans, which are very often one of the main aim or one of the main goal to get a final result from any type of documentation of architectural heritage. Let's say something about the workflow of documentation. The efficiency and interpretive value of any documentation project, it depends on a carefully planned workflow. I just want to make here as a separate, I wanted to make here as a separate slide. Maybe it's very obvious, but believe me, according to my let's say already long-term focus on dealing on the project, in which I have to communicate very often with people who are not so in 3D technology as maybe you are or my colleagues are. It's very important at the very beginning of each project to define the project objectives, to clarifying the required developers in consultation with the stakeholders. That's the point one. Define the goals, define the aims, ask them or ask yourself, if you are the chief of the project, what are the main goals and results you want or they want to get. If you will ask somebody else, the most common answer is that I want everything. I want totally everything. Give me all the data, give me all the process results, which is the most common answer. And which is the answer we are not very happy to listen to, because of course, usually we agreed and gave them all the raw data, all the processing, all the results. But a lot of people, they don't expect they will get literally hundreds of gigabytes of data or even almost like a tera or 2 terabyte of data. And they are very surprised because they are not able to open the 3D models, to work with them, and so on and so on. So at the beginning, really, it needs to clarify which way the results should be delivered and what kind of results or data which will be delivered. Of course, you have also to think about the data acquisition, even employing drones, static and mobile scanners, or geodetic GPS to capture imagery and spatial data. I think the drones and the GPS or the rover or the differential GPS is just the base you will need to use in any case of documentation of archaeological urban heritage. Of course, you should think also about the data processing in a way of registering, cleaning, merging point clouds, generating mesh surfaces, and applying the textures. This is what you will learn or you will get during your summer school, and this is the part of the real processing of the data set. The fourth step is the analytical extractions. This could be done by you, or this is also already the phase in which you will deliver the data to some colleague who is specialized in urban archaeology, or he wants to make some measuring there or whatever. So the analytical extractions mean you will create the plans in a vector way, even like create the sections or the elevations, everything what you need for the proper interpretation of the building. The vectorization and interpretation, it could be up to you, but mostly as we deliver the plans to the architectures, mostly they are providing those and other steps of processing by themselves. And of course, what you think about is to archiving and integration, like the storing output in a structured environment, ideally within a database full of all the data you collect, even with the interpretation phases of your colleagues and so on. And this is like very proper to use the HBIM databases. The workflow is not linear, but iterative and shaped by the interplay between archaeological interpretation, conservation requirements, and digital processing constraints. Let's go to the case study. I will take you, as I promised, to the area of Middle East. A concrete case study comes from Koya, a town located approximately 60 kilometers west of Erbil, which is a capital city of Iraqi Kurdistan. That means the northern part of Iraq. The historic core of Koya is remarkable for its compact fabric of 19th century architecture. Yet this building faces severe threats due to neglect, climatic changes and extremes, and material fragility. The hot, arid summers are followed by periods of intense rainfall and strong winds, and this causes a very rapid and quick destructions of structures built primarily from sun-dried and fire bricks or even stones. So the collapsing of the houses in the historical core of town Koya is very actual problem in this part of Iraqi Kurdistan, and that's why we decided 5 years ago with our team of German colleagues and of course the Kurdish colleagues, assistants, we decided to set a project for documentation of all historical buildings in the city center of Koya town. And even because we detect the collapse or the destruction is rapidly increasing, we decided to ask for a rescue project. Swiss from the Swiss government support, and we asked for a grant project for foundation called Aleph, which gave us a let's say rescue money or money for a rescue project, which was spent on the one of the dominant or the main dominant of this town of Koya, which is called Mahmud Aga Khan. You can see it in the middle of this picture. And this Khan is coming from the mid 19th century under the Ottoman rule. His function was as a caravanserai. That means like a multifactorial roadside inn or a hotel designed to accommodate traveling merchants and their caravans, so even the animals like camels, horses, and donkeys. Caravanserais provided lodging, stables, storage, and trading facilities, and thus were vital nodes in the historical infrastructure of commerce and cultural exchange. Here you can see the original image, how the entrance to this caravanserai or the building is called also the Khani Gaura. In translation, it means like a big khan, like a big house. So this is the entrance, and you can still how it works. There was an entrance, and in here, or on the left and on the right side, there were the storage rooms for the staff of the traders, and in the direction straight, there was the accommodation in first floor for the traders, and in the ground for their animals. The Khan was active, and it was still occupied until still in the first half of the 20th century. But afterwards, it started to collapse because nobody was taking care about it. It was very expensive, and it started to collapse very quickly, as you can see on the picture down in the slide. We, with the group of colleagues from Germany, who are architects dealing with the rescue project of restoration and even stabilization of endangered architecture in Middle East. So we decided that at first we will make a proper documentation of the current state of this Khani Gaura, and after our colleagues from the architecture company, they will create two projects. The first one, which we get money for and we were paid for, was the stabilization project. At first it was necessary to preserve the current state of the destructed Khani Gaura. And the second project or second aim was to create some paper project of possible restoration plans. Both of these big aims needed a proper documentation, which was done by our side as archaeologists. You can see our technical equipment. As I said, we are a little bit strict or restricted by what we are able to take with and what we are able to use, especially, of course, in the city centers, because of the security reason, and even the local people, they are very, very aware of any kind of technology, which they saw it, because as you probably know, the situation right now in Middle East, it's all the time very like so-so. And every time when we are using, for example, drone there, the people knows the drones, unfortunately, more as a gun than a technical equipment for some scientific research. So that's why we are using the Mavics or even the Mavics Mini, the small drones. And we are using the ground terrestrial laser scanners because they are totally okay. They are quite invisible for the people. They are not making any noise. We are using like the ordinary cameras for the ground structure from motion photogrammetry, and even the GPS, and I miss the rover which we are using there. It's coming from the Trimble site as well. The methods which we were using were combination. We didn't decide just to use the photogrammetry or just to use the laser scanning. As I said at the early beginning, all our group, it's about 10 people, we sit together and we discuss which type of outputs we should create, in which accuracy, and what for the outputs should be ready for. If we should focus on making like more detailed raster 3D models for presentation purposes, or even we should focus to create the most detailed and accurate vector ground plans, the sections, and so on. And after we set all the necessary information, our group of documenters, we sat together and we decided that we will combine those three methodological approaches. In this part, we need to combine both of the laser scanning methodology, even the static laser scanner, and even the mobile laser scanner, which is based usually on rotation of the mirrors, which you can see on the pictures. They are in front of the apparatus, and those methodologies overlap each other. The first stage of involved mobile laser scanning, which produced initial point clouds of areas inaccessible to static terrestrial laser scanner, where use the mobile laser scanner. That means we use the laser scanner. I will just show you, sorry. So in here, when you see the current state of the Khani Gauda, you can see that it's massively collapsed also in some parts. And those parts were like the collapsed partly, or even endangered some rooms of the Khan. We decided to cover by only the mobile laser scanner because of the safety reasons. When you are using the mobile laser scanner, it's totally okay when you want to scan, for example, some interior of the room, which ceiling is ready to collapse, or even it's already collapsed, so there's a massive garbage in it. You will just need to hold the scan for a couple of seconds or tens of seconds in the room just with your hand and take it out. It's not necessary to stand there, the big laser scanner, to leave it there, even you don't want to endanger so expensive machine by any touch with the material which could anytime fall from any part of the room, literally. So you can see the outputs at first from the mobile laser scanner. So this is the raw point cloud which we got from this part of documentation. Of course, the next step was to to make like a dense point cloud, which already started to looks like a proper 3D model. Of course, with the mobile laser scanner, we weren't focused just only on the interiors of the rooms, but as we were using it, and it's on the base that you are holding it and moving by yourself around the all object of interest, we were scanning the all object which was reachable by walk as well, to get a point cloud which could be in the future combined with a point cloud from the ground laser scanner to get the highest density of the of the outputs suitable for the interpolation for the raster output. In here you can see the quality of the interpolated raster in the 3D model, and in here is the result of the texture 3D model. At first sight it looks good, it looks very suitable, it was also, but please focus on the detail of the texture based from the camera, which is integrated as a part of this mobile laser scanner. Right now I can say the quality is not very well. This is the result of the scanning from the mobile laser. So as you can see, we were focused to scan all the interiors room or the room of interior, even in the ground plan or in the ground floor, even in the first floor. Some of them they were really full of garbage, so it wasn't safe to scan them like in a large way. But we try to do our best. In here, I hope it's visible a little bit. You can see the red stripes, which are in the, maybe there's one more now, one better image. The red stripes, which are in the courtyard of the caravanserai, those red stripes are the trajectories of the person who was walking with a mobile laser scanner. In this part, I have to say that this scanning and the time was done by our colleagues from the Czech Technical University, from the Faculty of Engineering, namely called Professor Pavelka and his son, the same named. They were so kind and they were able to make the scanning for us and gave us the results for all the data for processing. In comparison to this, or one more, there is a view of the creation of the sections based on the mobile laser scanner. So we can get also the semi-automatic extraction of the ground plan. In here, there is still in the raster phase. Even we can do the sections. In here, we tried to use the semi-automatic extraction of the vector ground plan. It worked, but let's say from 80% it was successful, and 20% of the drawn lines by AI we have to correct by ourselves. But it was it spares a lot of our time, to be honest. So in the future, definitely we would like to focus also in this topic of the semi-automatic, not extraction, but maybe redrawing the vector plans from the raster inputs. This is how it looked the second phase using with the terrestrial laser scanner. I'm pretty sure you already knows it or you were in touch with it. If not, it works on the base that you have to move it like systematic way. The best way is to put the laser scanner on one stand from which you can see at least one or it's best two other stands on which the scanner will be moved. This is because the output of the point cloud, which comes from every single stand port, must be registered with the second one coming from the next stage, and it must be registered together, even in a elevation way, even in a spatial way. So when you are preparing like a scanning with this apparat, again you have to observe the building or the object of your interest and just create a mental map of the stand orts in your head, and to be sure from, as I said, is a it's like a geodetic principle. From one standout should be visible the next two closest, which you can see it was except of one standout at the entrance. It was totally okay. That's why we got also the results. This is the raw point cloud. It's not the dense point cloud, but you can definitely see the difference. According to the mobile laser scanning, already this raw point cloud just extracting from the scanning, it's much more dense than the original one. And these are the outputs of the extraction of the ground plan. Even when you see the ground plan extracted from this static laser scanner, you can very well see the differences according to the previous one, especially in the courtyard where the detail of the scan is much more high quality, even in the 3D model, even in the orthophoto, even in the extracted ground plan in a hell shaded colorization as it is in here. Why we decided to use the drone documentation when we have reached so good, let's say, so great results, so accurate results, which can be very easily suitable just itself as a base ground for creation the necessary outputs for the whole project. The answer is the texturing. As I said, the first scanner, even the second scanner, the static one, has integrated cameras in this body, but the laser scanners are constructed to create a really laser scanner 3D model. They are not created to make a high quality textured 3D models. And as you saw the quality of the textures coming from the laser scanner, you can understand why we decided to fill this part or to help us to get better textures for the purposes of detected the building phases of the object, to detect some cracks or some quite invisible cracks. It was very, very important for the architects, which needs to mark them as a possible in danger for any part of the object. So it was needed to get as high resolution texture as we can get. So that's why we decided to make it by a photogrammetrical documentation, a classic one, like a structure from motion. From the drone, as I said, in this case, we were using the small Mavic. And the results which we got, of course, we extracted also the 3D models, but the point cloud extracted from the 3D models based on the drone was not so dense and not so accurate as from the laser scanner, which we were ready for. But if you can see the quality of the textures which were extracted or downloaded from the drone photogrammetrical result, they were much more high quality than from the laser scanning. Here you can see how the sun is looking right now. So these are the parts which we were focusing on. And even, of course, from the drone, we were able to create like a vertical orthophoto, which again were used in two ways. At first, just to detect how the whole khan and especially the roof parts look like, and detection of the already collapsed parts or detection of any other cracks or endangered areas, which could easily collapse very quickly. And because we were using the rover to get the registered point clouds from the laser scanner, but the quality, to be honest, of the differential GPS in the city center was not so high. We still have a mistake of the vertical accuracy about 10 centimeters and horizontal about 5 centimeters. For most of the archaeological purposes it is okay, but not for the architectural. If the architects ask you for proper documentation, it must be in millimeters, the accuracy, not even in this kind of enlarged errors for them. So that's why we also use the RTK on the drone, and we create an orthophoto plan, which in the next step was used as a base layer for ortho rectification or georeferencing, to be honest, because we didn't use the elevations, for georeferencing of the outputted 3D models coming from the laser scanning. And it helped. It helped. Right now, the accuracy is about 2 millimeters. And in one corner, I will show you a secret, it's about, let's say, 2 centimeters error, but it's totally okay when we knows it and the architecture can count with it. From the drone technology, we were even able, with a combination with laser scanner, because we were using the textures from the drone and apply it on the models, and in here the orthophoto views, the vertical orthophoto views for the facades of the interiors. So we were using this as also for these purposes of outputs, which are in scale, and immediately all the people can start to work on it. It's a high resolution detail, and the resolution of the outputted orthophoto is 2 or 3 centimeters. So it's totally enough to detect all the cracks, all the phases of its building and so on. So of course we make it for the whole four parts. Now to the final part of my lecture. Okay, we got a lot of data. We, let's say, succeed with the documentation. And now we should trade it somehow to a lot of colleagues. Even with the local people, we promise them, of course, to share it. Even with the authorities from the General Directorate of Antiquities, which is one of the highest instance in Kurdistan itself, even with our colleagues from the architectural company, even for us, for my colleagues, or my colleague who is dealing with historical development of the building, and so on. The most suitable way how to share all the data and how to deal with this topic of creation some platform in which you can upload all the data. It doesn't matter if it's a raster picture, if it's a point cloud, if it's a Word text file, if it's a JPEG picture, if it's a PDF or some CAT file, DXF, DWG. There's a platform which started, let's say, to be standardized in many countries, especially in the sphere of architectural heritage, as their archivation form. It's called like HBIM, and the HBIM just imagine it as a platform or even a software, or the best word I think is a database or a multi-database, in which the main object is the 3D model of the object of your interest, to which they are connected all the information, which are of course developed during all the analysis phases, with the help of your colleagues and distribution and so on. The HBIM context, it's not still, unfortunately, very common in Czech Republic. It's, let's say, on the very beginning. Also, the institutions, they are not ready for it because it needs proper hardware and software equipment. But, for example, in Italy. I don't know if somebody from you there, guys, are from Italy. As I read, since 2023, all the project dealing with historical heritage, according to new law, should be done and exported the results into the HBIM database system. When I spoke to my colleagues from Italy, it's still not working. Of course, they have dealing the same troubles. Most of the offices and the state institutions, they are not equipped by the proper technology, but it slowly developed as a style or a way how to deal with the large data sets, even with large data sets coming from the 3D modeling and 3D documentation. In our case, because we created this project, it's 4 years ago, I would like to proudly say to you that we were using the proper HBIM database systems from some software which we bought, but we did not. We didn't get a foundation for that. So we create like a little bit punk style HBIM system designed by our colleagues from the Czech Technical Institute, but it worked. Right now we are transported all the data to a proper database system, and we will use the open source system, which is called FreeCAD. If you want to start maybe with the HBIM, the FreeCAD is great start. It's very easy to access this program, and you can just check about the possibilities which it offers. From the commercial offer, the most common is the Autodesk Revit, the Archicad, or the Bentley Open Buildings Designer. Those are like, I'm not very familiar with it, to be honest. I know about how it works. I know what for is it. I know the structure. I know how to work with it, but how to create it, it's a little bit something different, quite different according to archaeology. So we have two of my colleagues who are right now hardly working on this knowledge of the HBIM. So it could be finally developed or stand as a integral part of the results which our technological science center will transport to our colleagues who ordered some work from us. Here you can see how the HBIM is doing. So it's based really on the 3D model, in our case also on the ground plans, in which you can easily detect the phases of the building's chronology of the Han. Even there were placed the architectural drawing. All this is in just, let's say, one file. Yeah, imagine it's like one website or one database in which you can find all these data. And of course, there are also implemented the photographical documentation, even with some textural comments and textual interpretation. This is also, you are looking on the phases of already processed stabilization phases, which were done as a next step, as I was talking about the documentation phase. So those were done with the help or under the supervision from the German colleagues, but all the work was done by the local people, which helps a lot as well, because the integration of the local people, it has like a reciprocity positive way on that they feel that they are part of the restoration phase. They are proud of it. And for us, it was great to hire them because they have the knowledge of the traditional way of the buildings of this specific architecture, which is quite different from the European style. And in here, you can see the final output, as I promised. So you can see the interpretation plan in a vector phase, which was created based on the laser scanner. So in all the details, in all the phases, and it was set or georeference on the orthophoto picture from the drone to get the most accurate output, which we are right now still working with, and to be honest, still looking for a bigger foundation project to save this excellent Khani Gaura for the future generation. In conclude, if I should reflect the usage of the techniques, the Koya project demonstrates both the strength and limitations, of course, of the current methods. The strengths can be named as the laser scanning ensured accurate geometry. Of course, the photogrammetry provide the high quality textures, and the integration of methods achieve a holistic representation. Those are all the positives. But also there are some limitations. The laser scanning generated a really massive data set, which required for us extensive processing time. And the biggest issue we were dealing with, we have to decrease the quality of the 3D model, which was transported for the local people, even for our colleagues, because they don't have proper hardware equipment to open it. So that's another question which you can think about. The photogrammetry, of course, was very sensitive to lighting conditions. We wasn't able to do the photogrammetry by the drone in the interiors. The conditions of the lights were very bad there. And even if we will help with some lamps, it won't work because there was a lot of garbage there and especially dust. So that was a big problem. The laser scanning lacked the resolution of static scanning, but that's what we know. And thus the methodological choices must be tailored to each project. Sometimes a simpler solution, such as multi-image photogrammetry, it can yield more efficient results. During this project, we were very happy to be able to use even the laser scanners, but to be honest, I think we won't fail also when we will use only the photogrammetry, meaning for the outer parts of the Khan, not for the interior parts. So thank you very much for your attention. I hope this example will take you to some part of the world, which is my totally passion. And I want to introduce it to you as well in the way of the usage of the 3D technology. Thank you very much.